Okay, here we go. Okay, here's a common mistake. People will look at this and they'll say, well, doesn't that fit a rule? If you factor out the 4, which is legal, so I would do that first. Okay, once we factor out the 4, it is true that the expanded E rule fits that pattern. Because the expanded E rule says e to the ax plus b. So a would be 4, b would be 0. This little piece does fit the expanded rule. But the rule doesn't allow you to just pick a little part of it. So the whole thing does not fit any rule. It's like way more complicated than any of the rules on the sheet. You cannot split with multiplication. Just like derivatives. With derivatives, you had to use the product rule or the quotient rule. We don't study those. We don't study antiderivative product or quotient rule in this class. So you can't do that. There's no quick algebra trick, so we have to do what's called a U substitution. It's technically known as anti-differentiation by substitution, but that's way too many words, so U substitution will suffice. Okay. So anyway, it's not hard. Just look at it and look at your rule sheet and say, none of the rules match that exactly. So I can't use the rules. I can't apply the rules to little pieces of it. The rule has to fit the whole thing. Okay. You always use, well, there are a few exceptions, so keep in mind there may be some exceptions, but 99% of the time in this class, when you have two functions being multiplied, it's either an algebra trick or U substitution. And with a little practice, you can figure out pretty quickly which is which. In this case, I've got two things multiplied. I'm going to do a U substitution. The first thing to figure out is what is, just read the name for me. Raise your hand, McKay. Thank you. The first thing to figure out is this function is of a specific form. It's e to a number. It's like it's e to something. Okay? With the rules, I have no rule for e to the something. Like here's your rules. I don't have a rule for e to the whatever. I have a rule for e to the x, but not just e to the whatever. Or I have a rule for e to the ax plus b, but again, not e to whatever I want. But when I'm looking at a U substitution, it's okay to think of this as just e to something. Okay? It's important to recognize the form. That's going to become crucial. Please.
How is that not like e to the ax plus b? So it's like e to the 4x plus 0?
It is true that this is e to the x plus b. For U substitution, you have a lot more flexibility, though. It can be e to the x squared, e to the x cubed, just e to the whatever. 2 points. The other of the two multiplying functions is of this form, something to a number. And it can pretty much be anything, just something to a number. That's this multiplying function. Questions? The other multiplying functions you'll run into will be these. You'll encounter situations where you have 1 over something. That'll be one of the two multiplying functions. Or you'll have the sine or cosine of something. And we don't find any other types than those, so except for a few exceptions which we'll worry about later. So. Okay? The reason why you must identify the form is we're going to make a U substitution, which means we're going to replace all of the x's with some form of a U variable instead. So I write down over here U equals. The choice of U is always the something. This function is e to the something. The something is 4x. The other multiplying function is something to a number. The something is e to the 4x subtract 2. Like that. Questions?
Please, how can we use the same variable?
Oh, because I'm only going to pick one of them. So at this point I have two choices. I'm going to show you a trick to figure out which choice is correct. Anybody else? Please, move in. You're good. Okay, I get that this process will feel a little weird this first time. It really does. It feels like, what the heck are we doing? And then suddenly we'll have the answer. Process. It's going to feel like black magic. Please do it. Shoot. Tell us.
So for the first few, it's just 4x. Why isn't it equal to 4x? Like how the second one is the same thing, equal to 4x minus 2. Why isn't it?
Gotcha. I'm going to have you answer it by just me giving you a little guidance. It'll help you see it better. Is that okay?
Yeah.
You start out by saying, I don't have, like this does not fit a rule. So I just put the pink sheet down. Next thing I notice is I have two things multiplying. I need to figure out the form. The first one is of the form e to the something. Your choice for u is always just the something. In the next one, the form is something to a number. The choice of u is always just the something. You see the difference? Did that answer your question? Okay. Anybody else? By the way, u isn't special. It could be w, and I've thought about doing that, but it spoils the fun of just saying over and over again strange things like u is the something, and I like it. It's good. It reminds me of the movie. Actually, it was Mikhail Dahl and Ellie Lysenko came up with this last night. Oh, it's just like that movie, The Help, where the housekeeper is teaching the little girl, and she says, "You is special. You is kind. You is something. You is e to the 4x minus 2." Okay. It's not that funny, but whatever. Okay. I like it. I've thought about changing to w, so you don't have this strange grammar going on off here long of like. Never mind. Okay. But I like it. It's fun. Okay. It's interesting. It would be painful for an English teacher to keep hearing these strange phrases. But u is always the something. Okay? U is always the something. U is special. U is smart. Okay, look. Here's the trick. The next step is to take the derivative of our choice. The derivative of u. Say it out loud, please. What is the derivative of 4x? 4. The derivative of what, like this 4x came from this function. The derivative of your choice must be the other function. The derivative of 4x is 4. 4 is not the other function. So this is not the correct pick. So I choose u in the strange grammar. I choose u by identifying the correct somethings. U is always the something. Then I take the derivative of that something. This came from the first of the two multiplying functions. The derivative should be this, but it's not even close. The derivative of 4x is 4. That's not this. So wrong choice.
So like for this sec, the u has to be the derivative of the second multiplicative factor.
And pay attention to this symbol. This says dx. So when I go here, I'm going to take the derivative of this in terms of x. So I'm going to go d over dx of u, and then d over dx of e to the 4x minus 2. This side I can't really do anything with, so that's just du over dx. This side I can. The derivative of e to the something is e to the something. multiplied by the derivative of that something. Review from last semester. The derivative 2 would be 0. Pause for questions. Please, John.
If it doesn't equal the other u, then will you not use u substitution?
Correct. Yeah, it's not going to work. U substitution does not always work. The good news for our class is if they give you an antiderivative, it's either going to be a formula, an algebra trick, or U substitution. They have never, ever in 70 years had a problem that was like, oh, there's no way to find it. Right? So it's going to work, one of the three. But U substitution may not be the method. Other questions here? No. So that's just 4. So now I have this. Du over dx equals 4 multiplied by e to the 4x. Okay. This works because you don't have to worry about a multiplying constant. Multiplying constants are always going to be factored out anyway. But notice how the choice of u, strange grammar again, the choice of u, when I took the derivative of my choice, I ended up with the other of the two multiplying functions. Because the multiplying 4 doesn't really matter. It's a perfect match.
So when you're looking at these, do you want that 4x, would you want that to equal the second derivative, and then you want the second one to equal the first one? Or does it really not?
You got the right idea. You've got two multiplying functions. You pick a u from each one. The pick from this one, when I take the derivative, it should be this one. And the other way around. Because it wasn't, that was the wrong choice. But this pick worked. Please.
You said the multiplying constant doesn't matter, so if it wasn't 4 and it was like a 2, would it still be right?
Yes, listen to Monet, please. Listen to Monet. When I looked at this result, this choice of u came from this function. So my derivative's got to be this function. I'm completely ignoring the 4. Because this could be 8, -5, it doesn't matter. As long as a multiplying constant times this is exactly this, we're good. Yeah, that was coincidence. More often they won't match that way. Like this number might be 6 or something. But that part doesn't matter. Multiplying constant, you're just going to factor out anyway.
Why'd you just like leave out the 5 for everything?
This one here,
Yeah.
it's going to show back up in a minute. But the first part of getting the process started is to identify, I know I'm being a little repetitive here, but two multiplying functions. In this case, it's e to the something, so the possible u is the something. Here it's something to a number. So the possible u choice is just the something, not the number. So right now I'm focused on just getting the right pick for u. The 5 will come back in a minute.
So like, should I write out like a flashcard that you could view the stuff that you agree?
Yes.
Okay.
Like, listen to what Gage just said. The whole key to this process is getting the right selection of u. Once you pick u correctly, grammar here is just horrible. Once you pick u correctly, this flows really nicely. It's just step by step. It's the same on every single problem.
What was you saying I should write out?
Describing the u substitution process is not like trivial. It just takes a few times doing it, and then things start to click. But what I always start with is I've got to have two functions that are multiplied. Those two functions must be of one of these 5 forms. And then your choice for u is always the something.
Both of them have to be like that.
So the first one was e to the something. Again, keep in mind, we will encounter a few exceptions in the future. We don't worry about those now. Once you get good at u substitution, the exceptions are not difficult. So. Okay, one other thing. as you do your homework, make sure you use this 2-column method. If you invent your own method, I'm not going to help you because it's way too confusing. Seriously. It's like trying to grade somebody's paper and they invented their own alphabet. Okay? So 2 columns. Over here is all of our work with you. This is the actual solution to the problem. So on the next line, you're going to write equals for antiderivative. Okay, notice we have 2 functions multiplying, so the order doesn't matter. Our pick for u came from this function. So we're going to list that one first, and we're going to substitute. U is, bad grammar again, u is e to the 4x minus 2. So I write u to the 5th. Questions? Please.
So actually, you substitute u for the one you took to reverse that word, and then you keep the other one.
So far. It's going to go away in a second. No? Okay? Keep in mind the main goal here. You're starting with an antiderivative where the variable is x. We are converting that to an antiderivative where the variable is u. So we're partway done, but we still got to get rid of this stuff. And it's all about using the equal sign correctly. So look over here. This is du divided by dx. We need to manipulate this so that we can find what this is the same as. So we want the dx over here with the e to the 4x. So we multiply both sides by dx. So I get du equals 4e to the 4x multiplied by dx. Question? If u substitution feels really strange the first time, totally normal. It doesn't take only a few problems before it's really not bad. I want to replace this right here. One of you see it. I need to know what is that the same as? The key is this. Close. Like if I put the 4 back in, it would work. In general, I find that it's easier to leave the 4 there and simply divide both sides of this equation, actually multiply both sides of this equation by 1/4. So I get this. Like that. Question? So now I've got it. 1/4 multiplied by du is exactly the same thing as e to the 4x dx. So up here I can replace like this. No, it's not.
You do you divided by 4 like another thing?
Same thing.
But would you recommend writing a 1/4? Does that make it easier?
I think it's easier to think of it as 1/4. I'm not saying that it necessarily is, but I do think it's
So it
easier.
doesn't really change.
It's the same thing. Multiplying by 1/4 is no different than dividing by 4. Okay, I have here 1, 2, 3 factors. One of the factors is a constant, so it can come out. So I have 4 multiplied by 1/4. Antiderivative of u to the 5th du. Successful. We started with an antiderivative where every variable was x. We now have an antiderivative where every variable is u. And it should be painfully obvious that this is way simpler than this. So now this fits the pink sheet. Yeah. When you're finding an antiderivative, you always end with the pink sheet. So you grab the pink sheet and you go, oh, that one's easy. That's just 1. That antiderivative is u to the 6th over 6. Done. Except that I need to remember, u is really, sounds like the movie again, u is really that. So I write for my final answer, e to the 4x minus 2. That's terrible. So e to the 4x minus 2. Oh, come on, brain. Like that, sorry. To the 6th power, all divided by 6. And then I remember that maybe there was a minus 7 or something, I don't know, so plus c. If you take the derivative of that, you will get what we started with.
Woo!
The first time a teacher showed me u substitution, I thought, like, magic. I don't know how that even worked. But it worked.
I still don't know how it works, but woo!
Yeah, there you go. The good news is they will never test you in this class on how it works. They only want to make sure you can do it. So you don't have to know the why of this one. You just have to be able to do the steps. So, question? Let's do another one. Cool. 24.